That's always good for the next presenters and presentation. We're going to listen to Mara Skoncin, and she's going to talk about how ICT affects school efficiency, also using PISA data.
Good afternoon, I'm Mara Skoncin from Politecnico di Milano. I'm going to present this working paper together with my colleague Tommaso Gasisti from Politecnico as well, that is related to the association between ICT, so digital devices, and school efficiency, looking at PISA 2022 data. So the paper, the study, stems from an increasing awareness, both from the research and the practitioner side, that is related to how ICT is shaping the educational production function. This is a matter that has been increasingly explored in research in the last couple of decades, and that has become crucial since the emergency outbreaking by the COVID-19. The way in which, in the research literature, ICT has been explored is by combining a double approach. The first one is exploring the ICT access and availability to students and schools, and on the other side, the ICT use for educational activities. So, on the one hand, whether the digital devices and resources are available, on the other hand, how they are used, how frequently and in which way. Let's say more on the effectiveness side, in terms of the relationship between ICT and student achievement, we do have mixed findings in the literature, in the sense that there is a literature review provided by Oder and colleagues that shows that there is no overall consensus about the relationship between the use of ICT and student achievement, even though a moderate use can be positive associated to better results. Also, there is much less attention to all the aspects that are related to non-cognitive sides in this respect. Well, actually, the evidence is even more limited when we talk about the efficiency of schools. So not only looking at the effectiveness, so how ICT can be used to increase the effectiveness, so student cognitive and non-cognitive results, but how ICT can shape the which inputs are transformed into outputs by schools. So we name this the way in which the school is more or less efficient. There are, of course, few exceptions in this regard. I mentioned these couple of studies because they also use OECD PISA data. One is by Bergoni and colleagues, in which the previous wave of PISA data has been explored by using a network approach and on European countries. And what the results show is that actually the way in which the intensity in which ICT is used affect efficiency more than the availability of resources. On the other hand, we have another study by Agassiz and colleagues that actually use the same set of data, but looking at countries from Latin America, and what they see is that actually the availability of resources affect efficiency more than its use. So, so in this regard, we have this kind of mixed evidence. So this paper is going to address two research questions. The first one is related to what is the level of efficiency of schools across European countries. This is, let's say, the setting we are looking at, and how much heterogeneity there is across country in this respect. And the second research question is related to how measures related to ICT availability and use are related to the level of school efficiency. To do so, as I mentioned, we are looking at European Union countries in order to have kind of homogeneity in terms of comparing different countries. Actually, we do have a set of 22 European Union countries because This is very much related to the data that we are considering, given that we are specifically looking at a questionnaire that is the ICT questionnaire that is indeed go into details about how ICT is used by students. And this is not mandatory in PISA, so that actually a subsample of 22 countries filled this questionnaire in the wave 2022. So we have a total number of nearly 5,500 schools. The school is our unit of analysis in this paper, and what we are doing more specifically is, in the first step, to answer the first research question, we adopt an efficiency model that is a data envelopment analysis. In detail, we are using a robust order M approach. So basically, we are comparing each school, that is our unit of analysis, with a set of randomly selected other schools with a bootstrap procedure in order to get results that are more robust indeed and stable. Also, we are considering the fact that actually schools are nested within countries, and there can be structural differences across countries. So this is why we compute both a kind of global efficiency score, considering all the schools together, but also we use a model that adopts meta-frontiers. That means that we also make an estimation that is within country. So in this way, we consider the fact that actually countries are different one another, and we can also explore this local efficiency score. In terms of inputs and outputs, so the approach of a DEA model is that basically what we estimate is the efficiency score, so the ability of a school as a unit of analysis to transform input into outputs, and in particular to maximize outputs given a certain amount of inputs. So as inputs we consider the socioeconomic index at average level in the school, the richness of educational resources in terms of infrastructural inputs, and then in terms of human resources, we do have the teacher-student ratio. Then as outputs, we consider both cognitive outcomes, so the school average test score in mathematics, science, and reading, as well as non-cognitive outcomes. In particular, in this first set of analysis, we are using two social-emotional skills indexes that are those related to empathy and curiosity. So here you can find some descriptive statistics at country level. In bold you see the minimum and maximum, just to show that there is kind of heterogeneity across countries in the 3 inputs and 5 outputs that we are considering. Then as a second step, so after having estimated the efficiency score for each school, we want to understand how ICT is related to those efficiency scores. So the way in which we are doing this is by using, also in this case, a machine learning approach. In particular, we use a random forest in each multi-level specification. So also in this case, we are considering the fact that actually schools are nested into countries. So also in this case, we are considering this nested structure of data. And our dependent variable, so our outcome of interest, is the efficiency score. And as a predictor, we control for variables that are related to the availability and use of ICT. So in detail, the availability, accessibility, and quality of digital resources, so whether the school has laptops, internet connection, but also the level of teacher skills. And then in terms of more use of digital resources, we have the frequency of use of digital resources, like the frequency of use of laptops, but also softwares, like digital learning games. Then the frequency and the intensity of use of digital resources in some specific subjects that are those tested by PISA in the cognitive part of the test. The frequency of use of digital resources to conduct some specific educational activities like analyzing data, making projects, and so. and finally some additional controls. Now, as a result, first, for the first step, the efficiency score that we get, what you find here is the aggregation at country level with the local and global score and the ratio between the two. So the local one is the one that considers those meta frontiers, so the within country comparison. What we find is that looking at the global level of efficiency, the average value is 0.87. That means that there is this 13% space for schools on average to improve compared to the benchmark, so to compare to the most efficient schools. While the overall efficiency score by considering the nested structure of data is 0.90, so that means that on average schools are a little bit closer to the country frontier than to the global one. We can also have a look at the distribution of those local and global efficiency scores, again by country. So what we see is that the blue distribution is the local scores within country, the red one is the global one. So for some countries, actually, the two distributions are quite different. For others, like Italy, they are quite overlapped. And then we get to the second step. So in the second step, we use the efficiency score as a dependent variable, and we see, let's say, how much the availability and use of ICT can help us in explaining the variability in the efficiency scores. This is the variable importance plot in the sense that the model gives us a ranking in the importance of the variables in terms of helping us to explain the variability in the efficiency score. And what we see is that the most relevant one are those related to the use of digital learning games and the use of digital devices to make own elaboration or own research. So basically, the use of ICT is more relevant than the pure availability of digital resources. Given that we are considering the nested structure of data, so the multi-level specification of the random forest, we also have the distribution of the random effect. So basically, these random effects tells us that there are structural differences across countries. So just for the fact that a specific school is within that country, that random effect tells us, let's say, the starting level of the efficiency score. And we can see that actually the percentage of variability explained by those random effects, so by those structural differences across countries, is about 13.6%. Then, what we can also do by using this kind of machine learning approach is that we can actually see the relationship between our dependent variables, the efficiency score, and the most relevant variables related to ICT. So what we see here is on the vertical axis, the efficiency score, on the horizontal axis, the Likert scale that is used for each of the most relevant variables for the use of ICT. And we can actually see that when we use this kind of approach, we actually relax the assumption of linearity between the dependent and independent variable. And we actually see that the relationship between the two variables is not linear, given that we have this kind of peak in the efficiency score when the use of digital devices is not very intense. So let's say that the efficiency reaches the maximum when actually we have a moderate use of ICT. We also have some variables for which instead the relationship is kind of more linear and positive. For example, the fact that the students use digital devices to find information about real-world problems. And also some relationship with the teacher willingness to use digital devices. So this is also affecting the efficiency score of schools. We also find something related to the availability of ICT. For example, an intense use of the school portal is positively related to the level of efficiency of the school. So to conclude, what we see is that looking at the variables that are more strongly related with the level of efficiency of the schools, we find that ICT use affects efficiency more than its availability. So our results are more in line with the findings by Bergone and colleagues, that is also on the European context. But the specific relationship between the ICT device or the way in which ICT is used and the efficiency score depend on the specific application. As a further developments, we would like to use composite indicator to consider a broader set of socio-emotional skills as an output, but also explore more differences across countries and reflect further on the mechanisms behind what we observe in terms of relationship between ICT and efficiency score. So this is it for now. Thank you very much.